Hi, so today I'll be talking about organic chemistry, and today I'll be talking about the topic of acids and bases extractions. Okay, so pretty much, right, when we are given some kind of solution, it usually contains some kind of acid, base, or neutral, or the mixture of all three. And usually they're given to us in a solid. And so you just have like a mix of like a white precipitate, and you're like, okay, how can I extract it? Well, that's the process of what we're going to explain. And so for a neutral, we don't essentially need to really mix it with anything, so that's going to be the last solution. And so first we could either go acid or base, but in this case, let's go with base. So a base usually can have like a amine group, like an NH2. An acid can sometimes have like a ketone or like a carboxylic acid, and those are indications that it's acidic. And so essentially, in order to extract these, you want to add the opposite. It's essentially an acid and base reaction. And so, for example, for a base, right, you would want to add a strong acid. And so, for example, strong acid would be a HCl. And then an acid-base reaction, when you add an acid to a base, you're actually going to protonate it. And what does protonate mean? Well, protonating essentially means, let's just give it a base. It's going to give the proton to the base. And so essentially the base is going to have a positive charge. And so what does it mean when a base has a positive charge? Well, essentially it therefore becomes water soluble. And how does it become water soluble? Well, let me explain. Well, we know H2O is a dipole, and we know base now is an ion because it's formally charged. And what do we know about ions and dipoles? Well, they react. It's favorable. And so this creates an ion-dipole interaction. And so if you were to add an acid, let's just draw it right here, and you were to add the acid, what you're going to have is you're going to have two layers now. And so at the top, you're going to have the neutral, and you're going to have the acid, but at the bottom, you're going to have the base with the water. And this is essentially called the aqueous layer. And like I said, when you pour in this acid, it's going to react with the base, and it's going to create this positive charge, and it's going to create ion-dipole interactions with water. So it becomes water soluble. And once it becomes water soluble, well, now it creates two layers because now it goes into the water. And now you're able to safely extract this both into a different flask. And so now you're left with essentially acid and neutral, and we want to take the neutral out last. So next we could do the acid. And so for acid, we would add a base or a strong base. So for example, in this case, let's do NaOH. And in an acid-base reaction, an NaOH actually, it deprotonates an acid. And so what happens is you're going to have NaOH plus an acid, and it's going to take the proton away. And so it's going to take the proton away. And so what happens is you're going to have a negatively charged acid, and you're going to have, well, in this case it would be Na, just sodium, and then the hydrogen would just react with OH just to become water. And what do we know? Well, now there's a negative charge, so it's an ion, and then water is also a dipole, and so we're going to make ion-dipole interactions. And so now this has become water soluble. It's favorable to react with water. And so what happens is now you're going to create two layers. You're going to create the neutral, and you're going to create the acid with the water. Oh, sorry. To mention in the very beginning, this is all, because it's essentially you first just get them in like a powder form, and so you need to react it all together. So you're going to react it all with the organic solvent. And so this is just going to mix everything up, and you're going to want to extract it. And so in this case, the neutral would be organic. And whatever's on the bottom, it always has the higher density. Well, it makes sense. When it's more dense, it's going to be on the bottom. Okay, and now you could extract the acid, and now you could extract the water. And now you could extract the neutral solution too. And so now you're like, okay, how am I going to convert these formally charged compounds into its regular compound? Well, that's the next process. Okay, so first for the neutral solution, usually the organic layer is the organic solvent, is very volatile. So what does that mean? Well, it can be easily vaporized, and so all you have to do is you would heat it. And what we would do about the base? I just stuttered right there. Okay, so for the base, which would be positively charged, we would want to make it basic. Sorry, I'm like blanking. This base, which is positively charged, is technically a weak acid. And so we would need to add a strong base to it. And so we would add some kind of solution like NaOH. And what's the NaOH going to do? Well, it's going to deprotonate the weak acid. And so what is it going to do? It's going to take that hydrogen away, and so the base can just become pure. And so what does this mean? Well, what's the purpose of this? Well, now that you have a base and it's no longer formally charged, what does that mean? Well, it can no longer create ion dipole interactions with water. And so now you're going to have this solution that's no longer soluble with water. And so what happens is we would put it in the solution that's cold, and this base would suddenly start to become little precipitates, and that's how we would be able to extract it. And that's the same goes for acids. And so this acid that was negatively charged, it's technically a weak base. And so in order to get the weak base back into the acid, we would add a strong acid. And so let's say we add HCl. And so what happens is when you add this HCl, it's going to protonate it. So what does that mean? It's going to give a hydrogen to the acid and convert it. Hydrogen plus to the weak base and convert it to an acid. And so like I said earlier, well, now it can no longer create ion dipole interactions with water. And so now you're going to have an insoluble compound with water. And so when you add it to a bucket of ice cold water, you're gonna start getting little precipitates. And now with these precipitates, all you have to do is, well, now you have two different solutions essentially. So you could just put it through the little filter, and then you would get the little precipitate on top, and at the bottom you would just get water. And that's how you would do it. And that's the organic chemistry extraction lab for acids and bases. If you enjoy, just subscribe to my channel. I just started this. This is just, really for me and my friends. But, let's just see where this goes. And thank you so much.